Hi, everybody, and welcome back to another installment of the EBI seminar series on science communication. Today, I will be joined by Dr. Shreeharsh Kelkar. This will be a two-parter, where in the first one, Shreeharsh joins us to talk about the history of AI and how it's led up to this point. The second part, released in a couple weeks, will be talking about the implications of modern AI and how it has had consequences on journalism and science together. We hope you stick around for part two, and thank you for watching this video. I'm joined today by Dr. Shreeharsh Kelkar. Shreeharsh is a lecturer here at UC Berkeley in the Interdisciplinary Studies department, where he works as an interpretive social scientist who studies how software and big data have changed workplaces, work practices, and expertise in different institutions. Thank you for joining us today, Shreeharsh. How are you?
Great to be here. Thank you for inviting me.
Of course. Thank you for being here. So I'm going to jump in with our first question, which is, could you give us a more detailed description of your current research?
Sure. So, as you said already, my research is really about trying to understand how software is changing workplaces, how it's changing what counts as expertise. So the manuscript I'm currently working on is trying to understand how the use of software and big data analysis in education is changing educational research. And there are sort of two theories about this. And one theory is that big data changes everything because we know exactly what everyone does at every second in time. So we never, so that will just allow us to understand them completely. And the other sort of contrasting idea to this is that it changes nothing. And in my research, I find that the answer is, of course, somewhere in between. It is correct that big data doesn't change everything. So the people had this view when big data analysis started that because they are capturing everything, they will now know everything. They will be able to understand people completely. But it doesn't work like that. So even if you capture every single click in an educational software program, right, you can't really tell why somebody is clicking on something, right? If somebody is watching a video and they click around the timeline, are they doing it because they don't understand? Are they doing it because they like it? These things are still a matter of interpretation. So even though you can capture all kinds of data, you still need interpretation to understand it, right? So in that sense, big data has not really changed educational research. But what it has done is that it has allowed educational researchers to think about different problems because of this data. So, before, for instance, if educational researchers thought about in terms of dropout, right? So some people finish a course, some people don't, and why? And then that question needs to be answered. The fact that you have all this big data means rather than thinking about, say, dropout, you start to think about engagement, right? So the conceptual vocabulary through which you can understand education can change because of big data analysis. So this is what I find, but it doesn't mean that, now that you have everything, you understand everything. You still need researchers to come up with problems and think about, interpret what people do. So that's what I'm working currently.
Perfect. And with that, a lot of your work centers around AI and its role in society. So there are currently a lot of ideas of what AI is circling around, whether it's based in movies or modern day inventions that claim to be AI. But what do you find AI to actually be?
Yeah, I think it's best to consider what AI is from a sort of more sociological and historical standpoint. So I'm a historian and sociologist. Um, so today, of course, the word is used sort of in a very generous way. Everything about software is often called AI. But I think if you think about it historically and sociologically, then the key word in AI is really intelligence, which is not an easy word to define. And typically, intelligence doesn't have a definition. At different times and places, people think of it in different ways. So it's like a container, and people stuff whatever they understand into that container. And the sort of first transition in the view of intelligence, and before sort of the age of mass production, intelligence was about skilled bodily labor, right? So the kind of work that an artisan does to make a pot, or a blacksmith does, or a carpenter does. But once we sort of shifted to factory labor, what counted as intelligence was sort of more managerial. So it's what the top level management sees happening in a factory. They know everything that is happening, and then they can make predictions based on it. They can anticipate what is happening. So this kind of sense of anticipation based on surveillance is what intelligence becomes in the age of mass production. And then there's a further transition when we have the digital computer, because the big part of a digital computer is its program, and a program is a set of instructions. So then computer science people say that, okay, intelligence is about that set of instructions that makes a program do what it does, right? So now we have further displaced intelligence from bodily labor, right? Now it's not just the view from the top, it's literally the sequence of instructions, right? Um, and and this applies not just to programs, right? So a chess program is intelligent because of its algorithm. And in the same way, AI people will say that human beings are intelligent because their minds are programs. Now intelligence has kind of shifted into this very disembodied view, right? It's about the instructions in your mind. So I think that helps explain some of the things that are happening in AI today. It's sort of trying to make a program do tasks. One other thing that has changed in recent times is that it's that the AI people today are very different from the AI people from 60 years ago. So 60 years ago, AI people also thought of themselves as cognitive scientists. They were not just interested in building programs; they were interested in using programs to understand how the human mind works. Today's AI people are sort of less interested in that. They are sort of more interested in building products, commercializing products, building products for specific tasks, even though, they may not be doing those tasks a human being would. They're not so much interested in understanding human beings anymore as much as building programs. So it's a more engineering oriented enterprise than a science oriented one.
So, expanding a little bit more on modern AI, what do you think are today's AI's general limitations and abilities?
So like I said, today's AI is engineering oriented, right? It's about getting computers to do tasks, even if human beings may not be doing those tasks the same way. And what we've seen in the last 20 years or so are advances in sort of two very specific kinds of tasks. And the reasons for that, I'll come to in a bit. And those two things are computer vision and natural language processing. So computer vision is about making computers or programs understand images, like what's in an image or a video. And the natural language processing, well, everybody knows ChatGPT now, is about sort of making programs understand sort of symbolic text, right? And the advances in these two things have been very, very impressive. I mean, it is the kinds of tasks that these programs do now were sort of imagined 60 years ago, but like nobody was able to actually make that happen, right? So we have sort of really big advances in these sorts of symbolic tasks of understanding images and understanding sort of text. What we don't have in today's AI is, I think, sort of tasks that are bodily tasks, right? So we have impressive robots, but we still don't have robots who can like do what an insect does or what a child does, right? So a child, if even like a 5-year-old child in a big room which is full of objects can skillfully navigate those objects and not fall over them and go from one end of the room to another, right? And they can do this repeatedly and almost without effort. But it's still hard for us to sort of make robots who can do that, right? And partly, like I said, this has part of the way we have now defined intelligence as sort of a more abstract activity, more like about processing symbols rather than doing sort of bodily labor. So I think today's AI is really good at that, especially in computer vision and NLP. It's not so good at doing things that involve sort of bodily labor, physical things. Now, of course, the reason they are able to do these NLP and computer vision things is in some sense because of the impressive amounts of data they have collected. So, we have lots of images today because of the internet. You can annotate those images. So because we have all these gigantic data sets, it has become, in some sense, possible to train programs to annotate images. And you can see those results everywhere. Like Facebook, will tell you all sorts of suggestions for annotating an image. ChatGPT will talk to you chat with you rather like an actual person. So yeah, these are, I think, the impressive things. What's not yet happened is sort of skilled bodily tasks that involve skilled bodily labor.
Perfect. So we've talked a lot about in these past couple questions how AI has changed over time, like in its abilities and its skills. But what changes have you seen on the public outlook on AI in recent years?
Yeah, as a historian, what you see is that AI seems to go through these cycles of hype and despair, right? So even in the 1950s, when it began, there were all sorts of grand predictions made about AI on the basis of like programs that could prove theorems or a very primitive program to play checkers. I mean, Herbert Simon, the famous economist, cognitive scientist, philosopher, psychologist. He was a great man. He's infamous rather, for making a pronouncement, I think in the early 1950s, that soon, a program is going to beat a grandmaster at chess. Um, and of course, that doesn't happen for another 50 years. But that kind of hype has always been central to AI, partly because this is often how AI people got funding, and it was sort of very central to the way it was situated in the culture. But of course, the early sort of hype died down, and then we had another sort of cycle of hype in the 80s around these new kinds of AI systems that were called expert systems. And again, the idea behind an expert system is that it's supposed to mimic experts. And there were some interesting, very successful early expert systems that were built. One was called Mycin. You might have heard of it. It could do what a doctor does. So you essentially give Mycin a list of symptoms, and then it is able to make a reasoned guess about what might be causing those symptoms. And the way Mycin worked was that it had this impressive set of rules that were built into it through which it could reason about something. But again, the idea didn't really scale. We had Mycin, but then people tried to make expert systems in other ways and it didn't work. So again, there was like this period of hype, and then there was this period of despair. And of course, now we are going through another period of hype around, the advances made in computer vision, the advances made in natural language processing. And again, these are impressive advances, but probably, when you have this hype cycle, you always end up in sort of, the hype, it has to happen in spurts. Now, what's interesting though is that I don't want to say that the hype around the previous ones yielded nothing. It's just that it didn't yield what was promised, right? So even though in the earliest stages of AI, we don't get the chess player, the program that's going to beat the chess player, the grandmaster, we still get a lot of advances in computer science from it. So, the idea of linked lists, you might have heard of linked lists, right? In programming, linked lists were a byproduct of AI research. To build these programs, they had to think about new data structures, and now we all use those data structures. Similarly, expert systems, we don't have them any longer, but you could argue all apps today that we have are expert systems, right? I use TurboTax for my taxes. Nobody calls it an expert system, but the ideas of expert systems in some sense have percolated everywhere, even though, we don't really have expert systems. Like the hype was too much, but then lots of gains were made, but nothing happened that equaled the hype. And I suspect something similar will happen today as well.
Thank you for checking out the EBI seminar series on science communication. If you've enjoyed this video, please feel free to like and subscribe to our channel for more content on how science is communicated. Be sure to follow along for future installments or check out our previous series and explore social media, which are all linked in the description below. Thanks for watching and see you next time.